Hi everybody, welcome back to the TETRIX RoboBench video series. This is Tim and we are ready to get started with activity 1 for our TETRIX PRIZM programming guide. So let me go ahead and as we get ready to roll into this first activity, cover a few things that kind of get us going with this first 5 getting started activities. There's 5 of those and those are all designed to use a minimal amount of equipment and get the software going as quickly as possible, get you up and going as quickly as possible. Before we start, I do want to make sure that I mention a couple things that are important as we go through these. Some basic things about the Arduino sketches. Sketch is what we refer to in the Arduino world as the program. So if I say sketch or say program, it's kind of one and the same thing. I'll try and remember to refer to them as sketches since that's what the Arduino environment calls them. But if you have trouble with that and think about programs, you're good. Sketches basically are kind of set up. So if you think about those as a basic set of rules that as you list instructions line by line, that is essentially what we call code in the C type environment. So think of it that way. The rules that are important to a sketch are often called syntax. Basically, think of syntax like grammar in our written language, and that's kind of the same thing. If we don't have things in syntax correctly, then the code won't execute correctly. And as we go through these getting started activities and then on into the taskbar activities, you'll see and hopefully get a feel for the rules of those syntax. So think about that. For those of you that are already comfortable in a C-type environment, I'm going to go ahead and enable you or encourage you to go ahead and look in the back of the programming guide. There's a full technical appendix that if you just want a list of the specific functions that we've created to work in that PRIZM library directly related to the PRIZM hardware, feel free to go ahead and jump ahead to that. And for the rest of us that need a little more help in walking through it step by step, remember these are going to be sequential and each one is going to build on information that we covered in the previous one. So I would encourage those of us like myself to walk through these step by step. So that being said, let's go ahead and let's talk about this first activity. Hello world. You might say, well, why hello world? Well, hello world traditionally is kind of the first program that a programmer would write in code. The idea being that you create a set of instructions or behaviors that somebody is going to be able to recognize as deliberate. It's not an accident, not something that nature would have created. It's a of specific activities that are visual or show up to the outside world that said somebody thought about these, somebody wrote them down, and these are a set of written behaviors or instructions that were created. So programs and computers that have displays, a lot of times that would just be writing hello world. Well, obviously the PRIZM hardware doesn't have an LCD, but it does have LEDs or light emitting diodes that we can actually blink in the hardware that would interact with the environment. We can see those. We can recognize that they're not a random behavior. There's thought behind them. It's deliberate and it's interacting with the world. So that's why we're calling this hello world or blinking our red LED. So let's go ahead and go over what you need in order to do this activity. There's several things that you need to gather up and make sure you have. Obviously, you need to have your PRIZM controller. You need to have a 12-volt battery from your TETRIX Max building system. You need to have the USB cable. You need to have the on-off or the power switch harness that comes with your PRIZM controller. And obviously, you need to have the computer with your software installed. So if you need to, take a minute, gather that all up, and we're going to go ahead and come back and get started on that. So if you've got all your equipment, the first thing that we want to do in the software is we want to go ahead and open our sketch. And to open our sketch, we're going to have to launch the software. So we went ahead, and I'm working on a Mac. I want to go ahead and make sure everybody's aware of the fact that Macs, PCs, Linux systems, that once we get into the Arduino software or Arduino environment itself, it's very much the same. The only difference is the pull-down menus are across the top of a screen on a Mac. On a Windows and Linux system, they're across the top of the window. Outside of that, the environment is very much exactly the same. So we're going to open our sketch, and you see that it should open up into a blank sketch that has a couple things in it, but across the top it'll be dated for the date that you actually open the sketch. But we want to open a very specific example of what we are going to recommend you do, called blinking the red LED. The reason being that we think one of the best ways to learn is to do by following examples. So we provided a written example that's ready to go. So if you go up to your menu options and you click on File, go down to the example that says Examples, you'll have a pop-out to the right, and you can go down to the one that says TETRIX PRIZM. Again, this is assuming that you've installed the PRIZM library. You haven't done that, you need to go back and install that PRIZM library. But in the pull-out to the right of that, you'll see in the list, Getting Started Activity 1, Blink Red LED. They're in order, so just go to the top of the list, click on that, and it should actually open up a brand new window that says Getting Started, Activity 1, Blink Red LED. I'm going to actually move these side by side so you can kind of get a comparison to a blank new window that we originally opened up and in the one that we have written for the Ready LED. Now, we're actually pretty close to ready to download this already. That's all it really takes. But before we do, we need to make our physical connections. So I'm going to start with those physical connections by hooking up my switch harness. So I'm going to take my cable. There are two ends, actually two connector ends, one for the battery, one for the PRIZM, two open ends that are on the red side of the wires that is going to attach to our switch. I'm going to take my switch. It does not matter which blade that you attach these to. So we can actually just apply our spade to one side and our second spade to the other open side. And now you see I have a basic triangle with my black wire solid from, or ground from the PRIZM to the battery. And then the red wire is interrupted with my switch so that when I flip that switch on or off, I'm interrupting power, and that gives us a way to turn the PRIZM on and off. Once I have that done, I need to finish my connection. So I can start by connecting to my PRIZM. I'm going to hold this like this. You see that the connections are basically color-coded. There are two open connections for our power. We want to make sure that we can use either one, but we only use one with our battery. So I'm going to just simply pop that in like that. Solid connection. I use the bottom one. Second one, it would be if I wanted to daisy chain or power a second device. I can use one battery to power multiple devices. Once I've done that connection, I'm ready to connect my battery. So again, that is a one-way connection. There, the connection is keyed. I can finish that connection just like that. And to test the whole thing, when I flip my switch, if my battery is charged, I should get a blue LED and then a solid green light that tells me the board is ready to go. So I'm going to flip that off just for a minute, because now that we've made our physical power circuit, I want to actually connect it to the computer. So take my USB cable, and this is an A-type end of a A to B USB cable. There's a corresponding USB port on the PRIZM. And you might ask why we use this larger A-type port, and that's because of the robustness of the connection. Again, this is a product that we feel like is very capable in a very robust type way. So rather than use the smaller connection that we felt might not be as durable, we went to an A connection. A lot of printers are still using this type of connection, so we thought it was a very viable connection for our PRIZM. So we're going to connect that to our USB, just like that. And then before we go ahead and connect to our computer, I want to talk for a minute in the software about the port options. Crossed in the software under Tools, there is an option that says our board. We want to make sure that in that board that we have Arduino Uno. Let me say that again. Arduino Uno is the option because that's what this Prism is. The architecture is based around the Arduino architecture. Is going to be seen by the computer. Make sure that's checked off in the list. Underneath that, under port, for a Mac, you will see that this is one area where they differ just a little bit. On a PC system, if we don't have anything plugged in, that port option will actually be grayed out. You won't even be able to highlight it. But on a Mac, there is an internal Bluetooth that's available, so it sees that as a port. You'll see under serial ports, there are none available for that. But when I actually plug my Prism in to my USB, and plug it in the right direction, and I power that on with my switch, I've got a blue light there, and I refresh my tools, I actually will see that the Arduino shows up under my port as something, a USB serial that it's already, because I've connected that to this computer before, it's there, it's checked as the one that is available for download, talking to it. Once I've confirmed that, it's simply a matter of going into our program window. Again, we want to be the active window. We want is getting started, Act 1, blink red LED. Across the top, there are a couple of buttons that are available. First one we want to look at is Verify. If I click on Verify, you'll actually see in the software window across the bottom right, it confirms that the software is valid. And then once I've done that, I can actually click Upload, and I'm going to hold the board up so we can see what happens, because I want you to look right up here, right next to the USB port. When I click Upload in the software and it begins sending data, we should see some yellow LEDs or orange LEDs that actually indicate information is going from the computer to the Prism. Once that information is finished, I will get a solid green LED across the bottom. Once I have that, I'm ready to actually execute my code. I can press my green button. Now, before I do, I want to point out that we should expect to see a red LED in the same area begin to flash based on our program code. Press that. Yep, there we go. We have a red LED and it is flashing. We've downloaded code and actually have it executing on our Prism. Not bad at all, right? Pretty simple. So let's talk about a little bit about what we've done. And I can stop that by pressing the red button. I can actually unplug my Prism. And as long as I still have power, still have my green LED, code is still available on the Prism to execute. So for our mobile robots, we could actually take it away from the computer, set it on the floor, set it wherever we needed to, and actually execute the code without being tethered to the computer. So let's, again, examine a little closer about what we did in the software, because now comes the fun part. We, in our knowledge base, or the part of the activity where we're actually building on the knowledge that we have, we concentrated on this activity about the connections that we made, connections to the power circuit, connections to the computer, the connections with the tool, under tools for the ports, being able to talk to everything. That was what we really were focusing on creating as a knowledge base to move forward. But we also want to talk in our executing the code and then moving forward portion of what we actually did in the software. There are several things in the sketch that we want to talk about. We're going to start by examining the functions that we specifically used in this particular code, the Prism.setRedLED high, where that's the snippet of code that actually turns the LED on. Underneath that, we have a delay that talks about basically, if you look to the right of that, the explanation is that that's what sets the duration of time before it moves to the next bit of code. That next bit of code is a Prism set red LED low, or in other words, turning the LED off, and with another delay. And that is all contained in our loop, or our main loop of what is executing in the code. Now, I want to go ahead and say that there are several other things a part of this sketch that we will cover in more detail as we go through the other activities. But for us now, that's the main part that we want to focus on this particular activity. And we can change some things. And let's try that. If we actually address the delays, we have, as a parameter, we have 1,000 milliseconds that is in those parentheses. That equates basically to 1 second. We can change that number. We can actually, if we wanted to say we wanted it to blink faster, we could actually put that in half. We could put 500 in. And the same way on the delay, we can change the delay on how long it stays off to 500. So I've cut the time in half for both of those. If I plug my USB cable back in and actually, again, verify my code, make sure that it's all correct, and then upload, you'll see the data being transmitted with my flashing orange lights. Once I have a solid green light, I'm ready to execute. And now you see I've got a faster blinking light. So I've changed the code with two very simple changes in my text environment that just deal with the parameter around the time. Pretty simple to do, right? I can stop that. And we could expand on that. We could change some other things. Maybe we could do a copy and paste, and we could add a second command that turns the LED on for a different period of time. And I encourage you to do that as part of this moving forward type of activity. But as an additional part of that, let's talk about why we would blink lights. Obviously, in a real-world type of environment, there's several things that we see all around us. We might see a traffic warning light that alerts us to potential hazardous behavior, blinking light. We might see something on a kitchen appliance that blinks and tells us when something is in process, and then it maybe turns to a solid different color afterwards, that as an indicator and lets us know where we're at in a process. So we see blinking lights or visual cues to what we're doing everywhere, and they're sometimes manual, so they're sometimes electronic. We've just done an example of an electronic controlled blinking exercise, but there's a lot of things that you could do with that, or we see in our everyday life that we actually probably take it for granted. But those are why you might want to do that in this particular environment. And then the other side of that is, how does this apply to your classroom? Well, from a STEM perspective, there's a lot of connections that we can make with that. We can talk about science and LEDs and what a light emitting diode is, and we've obviously worked with technology and computers and the engineering as far as what it took to create this, the materials that are involved with that, math, where we were working with the delays and the duration of those delays and changing the parameter there, frequency, those kind of things. So there's a lot of STEM connections that we can make with a very simple activity like this. So I would encourage you to look a little bit more in depth in the activities in the printed guide. And let me go ahead and make sure that everybody understands too, if you need a digital copy of the programming guide that is available for download, I would encourage you to take advantage of downloading that and having that as an extra resource, because there is additional information that you might want to look at and research out. And last but not least for this activity, we want to talk about the fun part, and that's hacking the code. Each one of the activities that we do with the Prism in the programming guide, we're encouraging you as the last part of kind of an open-ended challenge to take advantage of what you covered in the activity and hack that code and try it on your own. So I would encourage you to open up a new program, and that's pretty easy to do. I'll get you started on that. It's just under the File menu option. It's just simple. Click on the new, and you'll open up a brand new program, and you can go ahead and then, based on the example that we just did, you can begin to enter that text just like you would in any other kind of a text editor, Or you can do what we are comfortable with as far as our basic software skills, copy and paste. And you can choose different portions of that to try and recreate what we did and gave you as an example. I would encourage you to try and recreate that on your own as that next step in exploring what you can do with this first program. Hey, remember, blinking lights is just a portion of that. And if you think about the fact that over the years, that's been a traditional way for us to communicate via long distance in things like Morse code or different ways like that. So maybe you might want to try and recreate this hello world by blinking out, flashing hello world in Morse code. So again, hopefully you found that as inspirational. Hopefully you thought it wasn't too hard to do. But I would encourage you to experiment with that on your own and come back and see us, and we'll do activity number 2.